Welcome to The Explainer. Today we're diving into a field of science that steps in when literally everything else fails. I'm talking about forensic odontology. It's a discipline dealing with the absolute highest stakes imaginable. You know, giving an identity back to the unknown and bringing justice to genuinely impossible cases. We're going to see exactly how teeth, which are actually one of the most resilient structures in the human body, become these unbreakable witnesses. But before we get into the heavy science, I really want you to picture something truly chilling. Imagine you're keeping a bedside visual for your comatose daughter. She was badly injured in a horrific car accident. For days, you're just willing her to live. And then, miraculously, she starts to recover. She wakes up, drowsy, battered, and she begins to speak. But then, she corrects you when you call her by her name. And slowly, this horrifying realization dawns on you. The person in this bed is not the daughter you've been praying over. It's her friend.
Okay, let's dive into this, because this isn't just a thought experiment. This actually happened in a tragic case in America. Following a devastating crash where 5 people died, a sole survivor was airlifted to a hospital. Fellow staff and students had visually identified her. You see, the survivor and her deceased friend shared very similar features. We're talking blonde hair, gray-green eyes, the exact same build, even the same university. The family's actual daughter was already dead and had mistakenly been buried by the other family. This devastating mix-up proves an absolute truth in forensics. Visual identification, especially after severe trauma, is incredibly unreliable. That kind of heartbreaking failure is exactly why we need a rock-solid scientific solution. Enter forensic odontology. And this goes way beyond just looking at teeth, right? This is the rigorous collection, management, and interpretation of dental evidence for legal proceedings. Because a single error here causes immense, unnecessary distress for grieving families, this discipline demands absolute accuracy. Every single conclusion reached by a forensic odontologist has to be entirely free from subjectivity, emotion, and personal bias. Zero guesswork allowed. Now, while identifying the deceased, especially in mass disaster situations like a tsunami or a plane crash, is definitely their most common role, the work these experts do is incredibly varied. They do so much more than you might expect. We're talking age estimation for both the living and the dead, bite mark analysis. They investigate cases of suspected abuse by looking for specific dental trauma. They even compare tiny, shattered fragments of teeth found at crime scenes to help breathe life back into seemingly unsolvable cold cases. To understand the physical reality of these investigations, let's look at our first case study. A teenager stole a car after drinking, crashed on an unlit country lane, and tragically, the car caught fire. He was pronounced dead at the scene. Now, what's really interesting about what we're looking at here is the anterior or front teeth. You can clearly see how severely fractured and discolored they are. In high-impact collisions, these front teeth literally take the absolute brunt of the trauma. But contrast that severe damage with the posterior or back teeth of that exact same victim. It's almost miraculous. The orofacial structures, so the cheeks, the tongue, the jaw muscles, they act as this incredible natural shield. Because of that protection, these highly resilient posterior teeth and the metal amalgam restorations within them survived the extreme heat virtually intact. And those specific restorations, they were the exact clues needed to secure a positive identification. So, this brings us to the fundamental core of how dental identification actually works. Honestly, it's like a giant puzzle, and it is all about comparison. On one side, we have the antemortem records, the before-death records. These are the charts, the x-rays, the study models kept by a patient's dentist. And on the other side, we have the post-mortem findings, what the forensic odontologist meticulously documents during the examination of the deceased. The whole goal is to compare the two and look for an exact match, or at the very least, ensure that any discrepancies can be logically explained, maybe by the passage of time or a visit to a different dentist. Let's look at how this matching process works in action. What you're seeing here is an ante-mortem radiograph, an x-ray taken while the patient was alive, back in 2006. Notice the specific shapes of the restorations. Look closely at the distinct outlines, the curves, and how the materials sit right there within the natural roots of the teeth. This is exactly like a visual puzzle piece. Every single root canal, filling, or crown is basically a unique fingerprint left behind by the dentist. And this brilliantly illustrates what happens when those puzzle pieces snap together. Here is the post-mortem radiograph of the exact same individual taken in 2009. I mean, look at how perfectly it aligns with that ante-mortem record.
You can trace the exact same shapes of the restorations, the same distinct root structures, and because there's no minimum number of matching points required in forensic dentistry, as long as the features are uniquely identifiable, a perfect alignment like this secures a definitive positive identification. It brings the search to an end and offers that absolutely essential closure to a grieving family. Of course, it isn't always that easy. In fact, odontologists face massive hurdles, largely because of how dental records are maintained in the real world. For starters, there is no single international charting system, which creates absolute chaos and mass disasters. Dentists sometimes take incomplete or inaccurate notes, or, let's be honest, they just have completely illegible handwriting. Sometimes radiographs are poor quality, or files are just lost entirely. And these aren't just minor clerical errors, these frustrations actively delay the identification process, which, tragically, keeps families waiting in pure agony for news about their loved ones.
And the physical examination itself, that comes with its own set of intense challenges. Mortuary conditions can be incredibly tough. Things like rigor mortis, freezing, or severe burns make it very difficult just to access the oral cavity. On top of that, modern dentistry uses tooth-colored resins that blend perfectly with natural teeth. Those can be practically invisible under standard mortuary lighting unless you're using specialized UV flashlights. That is exactly why distinct, unmistakable metalwork, like the shining gold crown you see here, is incredibly valuable. It provides a rock-solid anchor point for identification.
Now, let's look at how all these tools, teeth, DNA, and public records actually come together to solve a true crime mystery. This is the case of the headless body. Day 1. A dog walker finds a burned, headless body. During the autopsy, investigators find fragments of an upper anterior porcelain crown in the stomach contents, likely swallowed by the victim during the attack. Then, months later, in a completely different county, a mutilated head is found partially buried in a school field, along with a 3-unit dental bridge. DNA analysis brilliantly links the head to the body, but they still don't know who it is. Finally, an anatomical artist reconstructs the face from skull fragments. It airs on a TV show called Crime Watch UK, and the public starts calling in with tips. One of those names leads investigators to a dental record featuring, you guessed it, 3 upper porcelain crowns. A perfect match. Thanks to forensic odontology, the victim got their name back, and a full-blown murder investigation was launched. Our final case is absolutely heartbreaking, but it really shows the profound depth of this science. In October 1997, an 8.5-year-old boy went missing in Manchester after playing on a bus. The following summer, skeletal remains, just a mandible and a pelvis, were found near a fast-flowing river. The dental age estimation placed the remains at 8.3 years old, which was a chilling match. But the crucial clue? Some of the posterior baby teeth were missing from the jawbone. A deep dive into local dental school records showed the missing boy had those exact baby teeth extracted under general anesthetic years prior. But they needed absolute certainty. Because standard DNA was too degraded, scientists extracted mitochondrial DNA, which, by the way, is maternally inherited and incredibly abundant in teeth. That allowed them to link it directly to the boy's mother. It was a tragic end for sure, but the science provided undeniable truth. So as we wrap up this explainer, I want to leave you with a provocative thought. Something that bridges the gap between this high-level forensic science and your everyday life. If the unthinkable happened, are your dental records accurate enough to tell your story? The science of forensic odontology is wildly capable, but at the end of the day, it is completely dependent on the meticulous care of the dental professionals we see every year. Keeping accurate, comprehensive records isn't just about good healthcare. It's about honoring the truth, ensuring justice, and ultimately providing closure. Thanks for joining me on this deep dive into the fascinating, unbreakable science of forensic odontology.